Recording in progress.
Okay, so when we're graphing a sine function, what you want to do is rely on the unit circle. So in many ways, the unit circle plays a key role in the way we graph sine or cosine. I'm not sure if we'll graph tangent or cosecant or secant cotangent. I have done that in the past years, but I think we'll probably just sine and cosine and kind of just go really deep with that. But we're graphing a sine function or cosine or any trig function. We want to rely on the unit circle. Now I'm going to do a makeshift unit circle right here. Kind of just do. You guys have your own. I know that. I know that's 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And then in the quadrants, because it's kind of hard to write, if I kind of do this, the first quadrant, here we go. I'm doing Q1 here. We know this is, well, what is this? If this is 30 degrees, let me do that. So if this is 30 degrees right here, or pi over 6, and let me change colors because that might show up a little better. Pi over 6. Okay. So remember the coordinates? You guys have your unit circle, or does anyone remember off the top of their head at pi over 6? You guys know what the coordinates would be? Some of the radicals.
It's 1/2.
Okay, one of them's 1/2. Good. The x is √3/2. And by the way, you get a unit circle. Don't worry, you still get a unit circle on our future assessments. But ultimately, the unit circle is like training wheels. Like, you know, we will take off the training wheels eventually, or you probably don't need them. Like you'll get to a point where you just know because you do so many. Because we do this whole semester, this stuff. Does anyone remember the ones at 45 degrees or? Yep. Thank you, Stella. Wow, you're on fire. Look at that. And then lastly, right here, that's right. Okay. Okay. So cool. Now, sine. What are you looking for when I ask you to find a sine of like pi over 6, or sine of pi over 2, or sine of pi over 3? What coordinate are you looking for? Good. Look for y coordinate. So for sine, you want the y coordinate on the unit circle. Now, technically, it's y over r, right? But what's r in the unit circle? 1, right? So you're looking for the y coordinate on the unit circle. So starting at 0, and let me go one more different color, go pink. So starting at 0, what's the y coordinate at 0 radians? 0. What's the y coordinate at pi over 2 radians? 1. What's the y coordinate at pi radians? Y coordinate 0. What's the y coordinate at 3 pi over 2? -1, and then back to 0 at 2 pi. Now, if you go backwards, I know it's kind of weird. And let me erase some stuff because now it's getting a little busy. So let me erase some stuff here. Yeah, because if you go backwards, right? So, and you'll see why I'm going backwards just a little bit. And then I'll do the graph down below. All right. Yeah, if I go backwards, I think we agree that's negative pi over 2. I think we've done that enough times. You can see why we spend all this time drawing angles, because we build upon that knowledge, right? When we do the new stuff in trig. So negative pi over 2 is going backwards, going clockwise. I know the coordinates here are 0, -1. What's the y coordinate there? -1. If I go to negative pi, where are my coordinates now? 0. So you can see it's kind of a sequence, right? it's kind of this pattern that we're noticing, like go 0, 1, 0, -1, 0, 1, 0, -1, so forth. If I go -3 pi over 2, it's 1, and then back to -2 pi, back to 0. Excuse me. So these are going to be your x coordinates. So things is like x, and things is like y for the graph. For y equals sine x, and I'll make this x instead of theta. So, because that's how you usually type it into Desmos or a graphing calculator, you just type y equals sine x. So if I plot it, it's going to look like this. So it's a wave. It's a wave that repeats itself. You see how like it has a peak, like a crescendo, and gets in the middle, then kind of like a trough. It gets back to the middle, back to a peak, back to the middle, down below, down below. So there's a repetition to it. A lot of repetition with graphs of trig functions. Before I get too carried away with the stuff down below, let me pull up my graphing calculator. I have an app that's really cool. Let's see here.
Yeah. I like it. Looks good.
I think the video picked up, Maggie.
What?
Because I'm recording a lesson. It's okay. So, no worries. It is a good haircut.
Does the mic reach that?
I don't know. You'll find out when I upload. YouTube. It's a playlist. Some, but I don't know. If you click on the front of the Schoology page, you see the playlist right there. Yeah, actually, I'll show you where it is right now. If you click right here. Yep, right there.
Did you do the Jeopardy one?
I didn't record that one now. Well, that's just too hard because I have to go back and forth. No, you guys are crazy. I should, right? I should get a GoPro cam. That would actually be better.
No,
That would be better. Yeah, you were like crazy.
No.
All right. Okay. Anyway. Okay. You guys are funny. All right. Now, if you go in the graphing calculator, type in sine x. It's gonna look kind of weird. Like if I just hit graph and just see what happens. I mean, it's okay, but what I would do personally, first off, make sure you're in the right mode. So whenever you graph in the calculator, by the way, stick with radian mode. You could do degrees if you wanted to. The problem. No, that's for elevation. You want to do degrees. I'm talking about graphs. They're fine. Well, I asked for degrees anyway, right? I said 2 nearest degree.
Right.
So you should be degrees. And you're given degrees, right? Yeah. So okay. If I degree, but like I can't really see much, right? Like it's kind of weird because it's expecting to go from 0 to 360, right? For a full circle. Like see here we have 0 and pi, 2 pi. 2 pi is 360. So it's kind of weird. So you want to be in radian mode when you graph.
How does that I'm confused on the
Difference.
between radian.
So if you look at the window for the graph's going from -10 to 10. Yeah, degrees goes from 0 to 360, right? So that's why it's not showing the whole graph. But 2 pi is roughly like 6.28 because pi is 3.14. But what I would do personally when I graph trig functions, I go to zoom and pick option 7. It resets the window that's more appropriate for a trig graph. What it actually does, it starts at -2 pi and ends at 2 pi, just like having a table. And it shows 2 cycles. Also adjust the y to go from 0 to 4 or 0 to -4. So it's a more proper window if you do Z trig. If I click on window, you'll even see that, oh yeah, that's roughly -2 pi to 2 pi. 1.57, by the way, that's pi over 2, just so you know, because pi is 3.14. So you can see that every tick mark is also a pi over 2 units. So it's kind of nice. Of course, Desmos is even better. So if you go to Desmos, if I do y equals sine x, see? Now, the only crappy thing is that the default is like these integers they use for the scale, but there's a toolbar. It's really neat. And you can tell it, hey, I want to go from negative 2 pi, just type in pi, to 2 pi. And my calculus students didn't even know this, so I was a little surprised. Maybe because of the pandemic, they didn't see that. You can change the step, and you can change the degrees of radians if you want to, but see how it does a more proper window. And you can see there's a point at pi of 2 comma 1, a point at 0 comma 0, point at pi comma 0, and so forth. So Desmos is kind of cool. And see again, a point 0 comma 0, pi of 2 comma 1, pi comma 0, and so forth. So there's the graph. So really what you're doing is you're taking the y coordinates of the unit circle and you're plotting it on the coordinate plane. That's what you're doing. You're taking all the y coordinates of the unit circle. It's like unraveling the unit circle. So some really cool activities, which I don't really know very well. But I'll try to figure out from another teacher if I could give you guys a more tactile activity to kind of see how it forms that curve. But it's like taking the unit circle and like making that graph.
Wait, so does it end
It never ends. It never ends. Never ends. Yeah, great question, actually, that Stella brought up. The domain, actually, let me do that again. And let me erase some stuff here. The domain is all real numbers. Because you could take sine of any value you want. It doesn't really matter. I could do a sine of like 1,025 degrees. Who cares? I could do a sine of like 1,256,000 degrees, right? So your domain is all real numbers. Yeah, that's actually a great observation. Should have brought that up. And the range, yeah, it hits a high of 1 and a low of -1. Or did you guys ever do interval notation in algebra 2? Yeah, interval notation looked like this. I'm going to start asking us to do more of that. Where you have these brackets. So it goes from -1 to 1 for y. So yeah, that's the sine graph. Now, some other finer details we need. Oh, okay, well, let me write it again. Sorry. Okay, I'll write it again here. I didn't realize that is down below. So yeah, the domain's this. The range is this. And you usually have 5 key points. You have a high at pi over 2 comma 1. We had a low at 3 pi over 2 comma -1. We had x-intercepts at 0, 0, pi comma 0, and 2 pi comma 0. And I'm not sure what's meant by this table here, but I'm going to kind of do my best to kind of add some color to this. So you want to use the y coordinates on the unit circle. On the graph y equals sine x. And of course, use the
Wait, why is the minimum? Why have to be higher?
because the low point's -1 there for y.
But there's also a low point of 1 to -5.
Yeah, we're just looking at the first cycle. I'm only looking at the first cycle from 0 to 2 pi.
Oh, okay.
But what I'm writing over here, of course, use the corresponding angles in radians as x coordinates on the graph. So you probably need to write that somewhere in the margin. Sorry, it's a lot of writing. But yeah, when you graph the sine curve, use the y coordinates in the circle as y coordinates on the graph of y sine x. and use the corresponding angles in radians as the x-coordinates on the graph. So like, for example, at pi of 2 in the circle, the y-coordinate was 1. So I take pi on the y on the graph of y cosine x. Or at pi, when we have pi radians, the coordinates are -1, 0, so the y-coordinate there is 0. So I got pi, 0 on the graph of y cosine x. Now, cycle. The cycle is how far the graph travels before repeating itself. Like today. How many classes do you guys have today? 4. And how long is each class? That's a cycle. Or sometimes we'll say like, you know, we go like A, B, C, D, then E, F, G, then A, B, C, D, and then we kind of like repeat. Like we have like we call it like a 7-day tumble, then we repeat. So the thing is just when there's repetition, right? So Damon, are you on your phone? Are you on your phone? Oh, okay. So I'll make sure. How far the graph travels before repeating itself. Okay. And the period is the length of one cycle. Kind of repetitive, I guess. With what I just wrote above, was the length of one cycle. So how long will one cycle be? Given that the graph looked, it's 2 pi, yeah. Which we'll get into just a little bit. I don't want to move the screen just yet. Let me know when I can move the screen. Good. Okay, Maggie's spoken. All right. So again, the graph kind of looks like this. I'm gonna do amplitude. Don't worry, I'll get there.
I didn't notice that.
So 0, pi, 2 pi, 1, so again, the cycle we already talked about. Period is length of one cycle. So for this case, for y equals sine x, period is 2 pi, but it can change.
We're gonna be learning different, like, here.
Yes, absolutely, 100%. We will. I'll explain how it changes. The amplitude is going to be high minus low divided by 2. So there's my high. There's my low. And more specifically, it's going to be the max y minus min y. I should have said that actually. Max y minus min y. What's the highest y coordinate? 1. What's the lowest y coordinate? So if you subtract 2 and divide by 2, what do you get? No, 1 minus -1, which is 2. 2 over 2 is 1. 1 minus -1?
Yeah, that's yeah.
No worries, it's all good. So you get 1. So really the amplitude is just this. Sometimes what I personally do is I'll just take a 5 point and see how far it gets, how long it is to get to the middle. So that's the amplitude. So for y equals sine x, the amplitude will be 1, but it can change. I'm going to show how it changes in just a little bit, but it can change. Okay. Actually, let's just see how it changes really quickly, then we'll do cosine. Let's go back to Desmos here. Okay. If I put a 2 out in front, the 2 in front of the sine x, what do you think the graph's going to do? Or hit 2, what do you think it's going to do?
Expand.
Expanded vertically. What if I did like 1/2? It shrunk. Or like 1/4, shrinks even more. What if I did 3? What if I did 4? So you can see that impacts the amplitude. The number in front of sine x, that impacts the amplitude. Okay. What if I put a 2 here? It happens more frequently, right? If the coefficient of x gets higher, the cycle gets faster and faster and faster and faster and so forth. Ooh, good question. I'll explain in just a sec. But if I do like 1/2 x, you see it's slower. It gets long, the cycle gets longer, right? Cycle gets even longer. If you do put a negative out front, flips. We should know this from algebra 2. This is why that's why transformations is so heavy in algebra 2, because it's a big part. By the time you finish trig, you guys will be cool at transformations. If you're iffy on transformations, you'll get better with it by the time you finish trig. Now, great question that Eric asked. What if I put negative? It actually causes a reflection about the y-axis. So it doesn't flip, but it flips about the y-axis. I don't know if we'll investigate that so much, but maybe when we get to identities, that's another topic in trig. But anyway, let's keep moving. So cosine. Cosine is going to be very similar to sine. Now remember, cosine, the co, in case you guys forgot, the co stands for complement of sine, which means it's a shift of 90 degrees or pi/2. It's gonna be you're gonna notice it's a shift of 90 degrees or pi/2, because co stands for the complement of sine, and complements when 2 angles add up to 90. And what you're gonna use, actually, I don't know why I'm doing that. What you're gonna use is you're gonna use the x coordinate on the unit circle. That was random. Okay, that's all right. I'll just I'm sure the other kids love it. So well, if everyone's wearing headphones, then everyone should talk, right? So there you go. All right, x coordinate unit circle. I'll do a makeshift unit circle right here. It looks like Houston Texans are New England Patriots colors. Okay. All right, so remember, you're only going to be focusing on the x coordinates. So it's kind of weird, but the x coordinate is going to be the y coordinates on the graph of cosine x. And these are my angles, obviously, right here. These are my angles. So at 0 radians, what's the x coordinate on the unit circle? 1, and it just alternates like this. It's an alternation pattern, and you repeat it on the other side as well. It's repetitive, just like sine. These are repetitive functions. There's a lot of repetition. So my plot is going to look like this. You have a point up here, a point here, a point here. It looks just like the sine. It's just shifted by 90 degrees. as it should be, because it's complement. So yeah, same kind of thing. It just shifted, right? So sine, if I go to Desmos again, is very similar to cosine. So let me just clear this for a moment. So cosine's in blue, sine's in red. See, they're very similar, just shifted by 90 degrees. So the peak, instead of being at pi over 2, it's almost like you took the red curve and moved it pi over 2 to the left. Or you took the blue curve and moved it pi over 2 to the right. That's all that's all it is. So the domain, same thing. I'll pull it down below. Domain's still gonna be negative pi, sorry, negative infinity to infinity. So all real numbers. The range still from -1 to 1. You're still gonna have 5 key points. And usually when you do the 5 key points, we'll focus on from 0 to 2 pi. That'll be the interval we'll focus on, just like we did in the previous page. So my max happens at 0, 1 and 2 pi 1. The min is at pi comma -1. The intercepts are here. I'm looking at from 0 to 2 pi.
Oh.
I'm on here. I mean, yes, they're infinite minimums, infinite maximums.
Yeah.
So I'm just trying to show you, if you focus on one particular interval, usually 0 to 2 pi is a very common interval to look at. So you have 0, 1, 0, 2 pi, sorry, 0, 1, 2 pi comma 1, and then the other one's 0. And we'll felt stuff down below, and then we'll do some changes, and we should be done with notes in about the next 10, 15 minutes. Yeah, we're cool? We good? Okay, great. Let's keep moving. So cosine curve, just like sine curve, but shifted by pi over 2 radians. And periodic function means repeats. Where y equals sine x and y equals cos x. The graphs repeat every 2 pi units. We'll get a chance to copy that down, then we'll talk about amplitude period. So down below here, A is what you multiply to sine x or cos x, and B is a coefficient of x, just so you know. So you can see, generally speaking, y equals a sine dx, y equals a cosine dx. We assume b is bigger than 0. If it's negative, we saw what happened, but we'll assume b is bigger than 0 for now. So the amplitude, just so you know, is a, just straight up. That's the amplitude. The period, not terribly obvious, but it's 2 pi over b. B is not the period, but B impacts the period. Keep that in mind. But it impacts. And let me, large B means shorter cycle. And B less than 1 means longer cycle. Which would make sense, right? Because if you make B a fraction like 1/2, now your period is 4 pi. That's longer. If your B is like 10, and 2 pi times pi over 5, that means the cycle is much shorter. It starts repeating more frequently. Short cycle, which means more frequent repetition. And B means longer cycle, which means less frequent repetition. Okay. Give you guys a chance to annotate your notes. Then we'll do a couple examples, and then I'll tell you guys the homework, and that's it. And feel free to use a calculator. Feel free to use Desmos. You guys are still getting your bearings straight. We're doing this over 2 weeks, so don't worry. Like if it's a little overwhelming, graphing takes a while. But we didn't just jump into graphing because you had one unit circle and all the other stuff, and be refreshed with SOHCAHTOA from geometry. Questions? You guys still jotting? I'll give you guys one more time. Okay, let me clear. So a couple examples and then we're done. Okay, so here A is 3 and B is 1. This means the amplitude equals 3. The period equals 2 pi over 1, which is just 2 pi. So this means that we're going to start at 0 and end at 2 pi. And because it's sine, you want 5 key points. And the key points usually look like this. Middle, high, middle, low, middle. So I start here in the middle. 1, 2, 3. -1, -2, -3. It looks like that. So only change you make the amplitude bigger. That's the only change. Let me rewrite that. Make the amplitude bigger. Versus sine x, you make the amplitude bigger. That's all. The periods stay the same. Yeah, still good.
When you're drawing, you want to like draw a line to
That's fine. You can end it. You can put endpoints. Yeah, I mean, some people will put like little arrows. Right?
Yeah.
Actually, we don't, because that might indicate it might go up or down forever. People just know when you're graphing trig, they know that this is what's happening.
So it's okay.
Yeah, that's fine. Yeah. Yes, but you're starting and ending in the same place. Because the period was 2 pi, so we only go up to 2 pi. Excuse me. But the amplitude changed. And plus, if we were plug in pi over 2, Like what if you plug in pi over 2? What do you get? We should know by now sine of pi over 2. If you look at the unit circle, sine of pi over 2 is 1. 3 times 1 is 3. That's why there's a y coordinate 3. Or what if I were to plug in pi? Sine of pi, if you look at the unit circle, is 0. Sine of pi is 0. This is why I spent so much time in the unit circle in the previous unit to get ready for this. So you get 0. So the y coordinate should be 0 there, right? And so forth. Last example, cos 2x. So your a is 1, your b is 2. So the amplitude is 1. The period is pi. Because the b value is higher, the cycle gets shorter, so it happens more frequently. Here's what's going to happen. That's we'll just do 1 and -1. Now it's cosine. So cosine, again, 5 key points. Now you can do high, middle, low, middle, high. So notice I'm not plugging in points. I kind of know the general feature, and I just make an adjustment if there's a period change. But the one thing that I have to keep in mind, though, remember, we start at 0, but now I'm going to end at pi. Why am I ending at pi? Because my period was pi. So what I'm going to do is I'm going to chop this up like that. I'm going to chop it up like this. If you want to draw that cycle, go for it if you want to. But if I'm drawing one cycle, you got to end at pi because of that v value. So don't get too carried away, like, okay, well, I'm just going to just graph 1 to pi or 2 pi, 3 pi, 2 pi. Personally, when I actually give you these problems, I don't actually label the axes. I'm going to ask you guys to label it. And then you just, label it, appropriately. Like, okay, I know it starts at 0, ends at pi, it has to end at pi because the period's pi, and then you have all the stuff in the middle. And it's yes, 100%, always 5 key points. So personally, like the way I would do this, like if I were just, do it on a test or something, I'd say, well, that's at 0, that's at pi, and I would deliberately chop this up in the quarters, like that. So that's pi over 2, that's pi over 4, that's 3 pi over 4. And see, I just do that. There we go. We can also graph in Desmos too. So anyway, that's our lesson for today. I do have time to do the tests. And homework is just going to be pages 1 and 2. It's just graphing this stuff. Feel free to use the answers I will put in.
Page 1 and 2 or from?
Page 1 and 2, 1 to 10. And I think it says homework number 7. Yeah, and finally the weather's cooled down too, which is good. Feels more like fall. All right.
Is it